Come 2022, a rare cosmic event will occur. This event, which happens once every 10,000 years, is also terrifying because it can destroy a whole solar system. We are talking about a magnificent star explosion that will be nothing like we have ever witnessed. Which star is exploding in 2022, and what does the explosion mean for our planet Earth? Star explosions are awe-inspiring events. In fact, there is no other event in nature that surpasses these events, known as supernovas, in the release of raw power. The flood of neutrinos accompanying the explosion of a single massive star releases as much instantaneous power as the rest of the visible universe combined. But what exactly is responsible for a star exploding? It is the star's core's fiery collapse. Here is how it works. When a star weighs more than about 8 times the Sun's mass, it burns through its hydrogen fuel quickly. The drama begins when a massive star runs low on one fuel and taps into another. The core contracts and grows hotter and denser until the previous nuclear reaction's ash undergoes fusion itself. After the hydrogen reservoir is used up, the star starts to burn helium, carbon, neon, oxygen, and silicon in that order. The problem, however, is that each successive fuel releases less energy, and the star burns through it faster. Moreover, once carbon ignites, the core's temperature approaches 1 billion degrees. Yes, 1 billion degrees. Neutrinos form and escape in greater numbers. These neutrinos quickly exit the star, and to compensate for the energy loss, the core burns its nuclear fuel even faster. A star's hydrogen supply may last about 10 million years, but the helium supply can last only 2 million years, while carbon finishes in just 2,000 years. The last phase, when the core fuses silicon, lasts less than 3 weeks. As silicon fusion ends, an Earth-sized iron-nickel core about 1.5 times the Sun's mass resides in the star's center. But iron group elements have nature's most tightly bound nuclei. Neutrinos stream from the core. The core's central density is so high that it forces electrons, which are the star's main pressure source, inside nuclei. The electrons transform some protons into neutrons. Both processes remove the pressure that supports the star. With pressure losses mounting and no new energy source to tap, the star's battle with gravity is over, and the next thing is a massive explosion. The iron core collapses at about 1/4 of the speed of light. In just a matter of a second or less, the stellar core, about the size of the Earth, transforms into a hot, dense proto-neutron star that is just 19 miles or 30 kilometers wide. When the central density reaches about twice that of an atomic nucleus, the core stiffens and rebounds thanks to a repulsive component in the strong nuclear force. This core bounce acts like a spherical piston that drives into the star's infalling gas. 2022 is a special year in cosmic history because scientists have predicted we might witness the full glory of an exploding star. The best part is that a piece of sophisticated equipment is not needed to track it because it will be visible to the naked eye in most parts of the world. What is even more special is that the type of explosion that will occur in 2022 is very rare. 2 stars will collide, and nobody has ever witnessed this phenomenon. As reported in a study from a team of researchers from Calvin College in Grand Rapids, Michigan, a binary star system will likely merge, causing a massive explosion. As such, scientists are looking forward to this rare chance to study this kind of explosion. It will cause a light outburst so bright that it will become the brightest object in the night sky. A binary star means 2 stars that orbit one another and are so close that they share an atmosphere. Watching the stellar system will offer valuable clues to the ways stars live and die, or perhaps point to some still mysterious force that can perturb the orbits of stars. The binary system predicted to merge in 2022 is the KIC 9832227. The team of researchers led by Professor Molnar has been observing this binary star system since 2013. Molnar got interested in KIC 9832227 when findings of its brightness changes were published. It led to questions about the nature of this star system. Molnar wanted to know whether it was a pulsar or a binary pair. Prior to the increased attention on KIC 9832227, astronomers didn't even know that the twinkling point of light was more than one star. But based on the timing and depth of those periodic eclipses, astronomers determined that one of the binary stars is about 40% larger than the Sun, while the other is just 1/3 the Sun's size. But as they rotate around each other, each one briefly blots out the other from the perspective of an observer from the Earth. After conducting their own observations using the Kelvin Observatory, Professor Molnar and his colleagues realized KIC 9832227 was what is known as a contact binary. This means it was a kind of binary star where the two stars are close enough to share an atmosphere. It is similar to the binary system known as V1309 Scorpii. V1309 Scorpii's stars shared an atmosphere and their orbit continued to decrease until they smashed into each other, causing a massive explosion and becoming a single star. Molnar's team expected the same fate to befall KIC 9832227, causing them to concentrate on the binary star system. KIC 9832227 is about 1,800 light-years away. If the merger event is anything like the 2008 explosion, it'll take about 6 months to rise to its full brightness, which is about 10,000 times greater than the brightness of the original. One of the first steps in the study of KIC 9832227 was making spectroscopic observations to see if their observations could be explained by the presence of a companion star. But the presence of a third star was quickly ruled out. The team's next task was the critical one, measuring the pair's orbital period. The purpose was to confirm if it was actually getting shorter over time, indicating the stars were approaching each other and a collision was imminent. It involved processing more than 32,000 images. By 2015, Professor Molnar and his team determined that the stars would eventually collide, resulting in a kind of stellar explosion known as a red nova. A red nova explosion is somewhere between the brightness of a cataclysmic supernova and a more standard classical nova. Initially, they estimated this would take place between 2018 and 2020, but revised the date to 2022. Molnar and his colleagues predicted that the burst of light it would cause would be bright enough to be seen from Earth. The star will be visible as part of the constellation Cygnus, and it will appear as an additional star in the familiar Northern Cross star pattern. As mentioned earlier, the findings of Molnar and co. is a historic case because no astronomer has ever been able to accurately predict when and where a stellar collision would take place. The team has reasons to be proud of their work. This discovery is very significant because it's not the usual way discoveries go. Most big scientific projects are carried out by groups with thousands of people and a budget spanning billions of dollars. However, Molnar's project was the exact opposite. It is basically being done using a small telescope with one professor and a few students looking for seemingly something that is not likely. Molnar assures amateur astronomers that they can track KIC 9832227's orbital timing and variations in brightness, but they won't be the only one that would enjoy the spectacle of the exploding star in 2022 because you won't need any special equipment to do so. This is a once-in-a-lifetime event, so it is okay to get excited about it. Just keep gazing in the Northern Hemisphere. Molnar and co. have continued to monitor KIC 9832227 pending its explosion. This they have done with the help of the NROA's Very Large Array VLA, NASA's Infrared Telescope Facility, Mauna Kea, and the ESA's XMM Newton spacecraft. These observatories will study the star's radio, infrared, and X-ray emissions, respectively. Perhaps with Molnar's pioneering work, it will become possible to predict supernovas like this in the future. Interestingly, there is even a documentary film about this historical discovery titled Luminous. The documentary, directed by Sam Smart, a Calvin professor of communication arts and sciences, lets you follow the process that led Professor Molnar and his team to make this unprecedented discovery. The documentary will also include footage of the red nova as it happens in 2022. Simulated, of course, it is expected to be released sometime in 2023. Let's hear what you think of colliding stars in the comments section below.